this assessment, we give the structure that corresponds with the name on screen. Now we can start this by recognizing that it's going to be a cyclohex, which means we can go ahead and draw our 6-membered ring. If we finish the name, it's a cyclohex 2-enone. That tells us that there's going to be a ketone. Because it's a ketone, we're going to assume that this is carbon 1. That's carbon 1 of the cyclohexanone at this point. To make it a cyclohex 2-enone, we need to put a double bond. Well, where do we need to put it? If this is carbon 1, the 2 is in front of the en, that tells us that the alkene is going to be here. So this is cyclohex 2-enone. All we have to do now is put in the chlorine. So we're going carbon 1, 2, 3, 4, 5. The chlorine will be at this carbon. There will be a chlorine and a hydrogen at that carbon. I've gone ahead and drawn a bold bond and a dashed bond because we have to make the stereochemistry R. And so the question is, where do we want that group to be? Where do we want the chlorine to be to make it R? Well, let's imagine that the chlorine is coming forward. If it's coming forward, then when we do the priorities, it's going to be carbon versus carbon, those are tied. Carbon versus carbon, those are tied. This carbon is attached to 2 oxygens. This carbon is attached to 2 carbons. We're saying 2 oxygens and 2 carbons because of the phantom bonds. So we know that this will be priority 2, and this side will be priority 3. The chlorine will be priority 1. If the chlorine is coming forward, then when we go 1 to 2 to 3, we're going counterclockwise. That would be S with the lowest priority substituent back. And so what we want instead is chlorine to be back and hydrogen to be coming forward. Let's confirm we're going from 1 to 2 to 3. We're going counterclockwise with the lowest priority substituent coming forward. That would flip to be clockwise if the lowest priority substituent would be back. And so this is the R compound and the answer to this assessment.